Lads, what we get here is this. Joan wants to find out if a six-sided dice is biased. She throws it 600 times. Is 600 times an adequate amount? Yeah. I'd expect that each one should be on 100. Because you'd be expecting that each one should turn up 100, okay? So, for this die, calculate the experimental probability of obtaining a 4. Experimental probability means what happened according to your experiment. Is 130 divided by 600. Yes, Sean?
How can the dice be biased?
It can be weighted. You can put a weight in it that favours one side over the other. So back in the day, like not anymore because there's industrial regulations, but casinos back in the day, they'd bias their coin to a certain side to make more money. So you can just weight it like with a tiny bit of metal will increase the probability of one result over another.
You say that like, you know, the dice, right, it's like kind of in dots and kind of carved into them.
Yeah, that could potentially bias it, but it's so little that one biased it enough to be noticed, I'd say. But you're right, I reckon there is a ever so slight bias.
But they wouldn't like purposely make the indents more on one side.
I don't know what they do, I don't work in casino business. Shh. Okay guys, it was a fair dice guys. How many 4s should I get? What's my probability of getting a 4 with a fair dice? 1 out of 6, or 100 out of 600 is 1 out of 6. Okay, does your answer suggest that Joan's dice is fair? Is it fair? I'd argue that this 56 here is well off the mark. 56 out of 600, it should be close to a 6th, but as we can see 56 is a long way away from 100, so that's 7 out of 75. So I would argue on the basis of this result here and this result here that Joan's dice is in fact biased. It's damaged in some way that's favouring one or two outcomes over the others. Okay, now there is a chance that it's not biased, but that chance of that happening is minimal. Okay. Now, if you go to number 8, it goes Neil, Tara each roll a die 180 times. Okay. So if each set has its own set of values. So that's all of Nina's results added together. This is all of Neil's results added together, and the last one is all of Tara's results added together. So they should all total, when you add them all downwards, how much should each one total? They should all total 180, because that's how many times you tried it. So for instance, Nina got 39 3s, Neil got 27 5s, Tara got 60 1s. Okay, that's what the results table means. Now, whose dice was fair? If you throw it 180 times, what is it on average you should get? For six possibilities. You should get 30. Which one is as close to 30 as possible? Neil's results are all very close to 30. Tara has a 60 and a 13, which means that her dice is definitely biased. And Nina has a 14 and a 39 and a 38. So we can obviously see that Neil's dice is the most fair in our opinion. Whose dice is the most biased? I'm going for Tara because of that 60.
Does it explain the answer knowledge? You have to say right.
On average, each result should be very close to 30. Neil's results.
Yeah, I know how to, but you have to explain it.
Yes.
Okay.
Yeah, Sean.
To get the answer, do you plus the results of the
Okay, lads. Bill has a 6-sided dice. He has 4 1s and 2 2s. He rolls the die 8 times and gets a score of 1 twice. Bill thinks the dice is not fair. Do you agree with Bill? Explain your answer. Okay, so my probability of getting a 1 is 2 in 3. My probability of getting a 2 is 1 in 3. Would you agree with that? Or 4 out of 6 and 2 out of 6. Does everybody see that? If there's 2 2s, Dennis.
Sorry. 2
happens twice, that's 2 out of 6. 1 happens 4 times, that's 4 out of 6. Multiply that by how many times you threw it. Okay? And he's saying that he gets a score of 1 twice. How many 1s should he get?
4.
You should roughly get 8 multiplied by 2 out of 3. Won't be an even number. So he has a 2 in 3 chance of getting a number 1. He rolls it 8 times. He should roughly get 5. Do you think his dice is biased?
No, you rolled 8 times.
He only rolled it 8 times. So there's 2 possible arguments that get you full marks here. You could argue, well, out of the 8 times, getting it only getting it twice is miles away from 5. I think it's biased. That gets you full marks. Other argument is he only rolled it 8 times. He needs to roll it much more to tell if it's biased for sure. Both answers get you full marks provided you present a valid argument. Okay? Bill has another 6-sided die with 1 4, so that's 1 out of 6, 2 out of 6 for 5s, and 3 out of 6 for 6s. He chose the dice 450 times. The results are as follows. That means he has a 1 in 6 chance of getting the 4. He has a 2 in 6 chance of getting the 5, and a 3 in 6 chance of getting the 6. So guys, look what we do here. How many times does he roll it? 450 times. What's 450 multiplied by 1/6? That's how many times he should get a 4. He should get a 4 75 times. How many times should he get a 5? 2 in 6 times. Because there's 2 sides that read 5. That gets me 150. And finally the last one is half the time, and half the time is 225. How do you think your theoretical results match up to your experimental results?
Pretty well.
I think they match up quite closely, therefore I think the dice is fair. That's it. I did 2